Problem number 2, it says a cup of boiling water is placed in a room to cool. The temperature of the room is 20 degrees Celsius. This situation can be modeled by the exponential function t equals a plus b times k to the negative m power, where t is the temperature of the water in degrees Celsius and m is the number of minutes for which the cup has been placed in the room. A sketch of the situation is given as follows. So letter A says to explain why a equals 20. Now, again, you kind of need to think back and remember properties of exponential functions. So this a value in the equation, and if we kind of look at the sketch of the graph, okay, notice that they tell us the temperature of the room is 20 degrees Celsius. That is where they're getting this a value of 20 from. And the reason why a is 20, and what we would want you to write down, is because the room temperature is 20 degrees Celsius, and the water temperature will not go below that. So the 20 kind of acts as an asymptote. Our graph is never going to cross 20 on the y-axis because with the room temperature being 20 degrees Celsius, and there's no outside factors, like they're not putting ice in it, they're not using a fan or anything to cool it further, so the water will never get below that room temperature. Before part B, it says initially at m equals 0, the temperature of the water is 100 degrees Celsius. So that means no time has passed. The initial boiling point is at 100 degrees Celsius, and they want us to find the value of B. All right, so we can plug this 100 degrees Celsius in, as well as our A value of 20 from part A. So we would have 100 equals 20 plus, let me look at the equation, B, times K to the 0 power. We don't know what B is, and we don't know what K is. They want us to find B. Now, anything to the 0 power, remember that rule of exponents is 1. So this can be simplified to be 100 equals 20 plus B, because B times 1 is just B. And if we subtract 20 from both sides, we're going to get that B equals 80. Moving on, it says after being placed in the room for 1 minute, the temperature of the water is 84 degrees Celsius. Show that K equals 1.25. All right, so now here they tell us the temperature, or T, is 84. They tell us the time is 1 minute, and that's our M value. And so now that we know B and we know A, we can plug all these numbers in and solve for K. So the initial equation should be 84 equals 20 plus 80 times K to the negative first power. Now we need to just solve for K. This turns into an algebraic problem. I can subtract 20 from both sides and get 64 equals 80 times K to the negative first. Divide both sides by 80. Okay, so I would have 64 divided by 80 equals K to the negative first. And then since K is being raised to the negative first power, we would need to take the negative first root of both sides to get K by itself. So if I, on my calculator, do the negative first root of 64 over 80, to do the negative first root, I first need to type in -1, since that is the power, or the exponent before the root. Then I can hit the math button, go down to option number 5, and then type in the 64 over 80. And remember, we should get a value of 1.25. My calculator says 5/4, but if I take 5 divided by 4, I get 1.25.